Hi, we're going to look on the second part for the chapter 5 refrigeration cycle. In this part, we're going to look on the actual refrigeration cycle that we consider several cases that actual happen on the analyzing the our design. So the first one is that the process for the refrigeration cycle is that occurs on the turbine is isentropic, but in actual condition the turbine is have some losses. So thus the entropy is generated due to the several several factors. Okay, so before that we have to put, this is a little bit improvement that you have to do for the slide, where you have to put all the arrows for all the processes, like for example 1 to 2, 2 to 3, 3 to 4. Okay, so go back to here. So this is the entropy is generated between the process 1 to 2 that will create the entropy generation. So the entropy is due to the several several factors. For example, the frictions, and then friction loss. Then also it can be because of the flow itself, and then also due to the heat transfer. Okay, so this is a key factor for the entropy generation in the compression process. So thus the actual from the we deviate from the power compression of the isentropic power compression, then will increase more power that will be required to compress to our desired pressure. So this is a WC actual. So with that, we can evaluate the effect of the irreversibilities from the compression process by evaluate the compressor efficiency. So the compressor efficiency is given by the power of the isentropic process divided by the power for the actual process, which is give you the m dot h2s divided by h1 divided by m dot h2 minus h1. So since the mass flow rate is equal, so then our compressor efficiency can become like these equations. Okay, so usually the compressor range is about nearly 70 to 80%. So it depends on the design itself. So this is the common range for the compressor. But as the compressor running through all over the years of the operation, the efficiency of the compressor will be reduced due to the several problems. Okay, so this is assignment number 2. So please do this assignment and do the submission by 30th of May 2020 by 5 p.m. Okay. So this is this is by using, okay, you have to calculate the compressor efficiency. Okay, and then actual cycle, another actual cycle that you have to consider, which is at the exit of the evaporator. It is not exit as the saturated vapor, but there will be some increment of the pressure of the temperature with a similar pressure that will end up the end of the process of the evaporator will enter at the saturated superheated region. So this is to ensure that the the fluid enter to the compressor with the superheated region or dry fluid. So the third one is the subcooling process, which is at the condenser, happen at the state 3, where the condenser will expel the heat until the refrigerant at the compressed liquid region. Okay, so don't forget to put all the arrows for the slight improvement. Okay, so yeah, so this is an example. We're going to discuss the example during the class. Yeah, so please attend my Google Meet class. And then this is assignment number 3. So please submit it by 30 of May 2020 by 5 p.m. Okay. So